All right, my dear kids. So, welcome to FIZIX Coach again, and I'm your Arun sir. We'll be studying the second lecture of the first chapter of physics, that is force. Already, what we have studied in this is we have already studied what is force. We have studied its definition, its mathematical formula, and its unit. What is the unit of force? Unit of force is Newton. SI unit of force is Newton, and the CGS unit of force is Diane. All right, and what is the relation between them? You need to remember that. All right, I won't tell you, just go back to the video and check it out if you don't remember. All right, so after understanding the concepts of what is force, its units, its mathematical formula, and effects of forces, we are moving on to the next topic, which is balanced and unbalanced forces. All right, so let us understand what is balanced forces and unbalanced forces. First of all, let us understand with this example. All right, in the first figure, you can see that two boys are trying to push this box, right? And they're applying the force on the same direction, right? Obviously, what will happen, these two, the green one and the yellow one, both the forces by both the boys would be adding up together because the direction is same, and the box would start moving. All right. Now, what if they start applying force in opposite direction? There are possibilities that the object may move in either of the directions. What do I mean by that? See, if say this is force 1 and this is force 2, so whichever force would be greater, the object will start moving in that particular direction. That means if F1 is greater than F2, then object will move in this particular direction. And if F2 is greater than F1, then object will move in this direction. All right, these are the two conditions, and one more condition is there. See, if F1 is equal to F2, then what will happen? In that case, the forces will be equal, but the directions will be opposite. Their directions are opposite, right? So in this case, when F1 and F2 are equal, then the object will not move. Yes or no? Yes. So this is the condition when the forces applied in opposite direction, they are equal, and the object is either not changing its position or changing its state of rest, right? It is stationary. That ways we can say that the forces are balanced, right? So in one line, what we can understand, in case of balanced forces, the value of the forces, or you can say the magnitude of the forces, is equal, but their direction is opposite. In that case, the forces will be said to be in balanced, or you can call them balanced forces. Yes? Now, there is one question which is very important here is, in case of balanced forces, is the object, or will the object remain in rest always? No. See, if the object is already at rest and balanced forces are acting on it, then it will remain at rest. But if an object is moving with a uniform velocity already, uniform speed already, then if some balanced force is applied on it, then there won't be any increase or decrease in the speed. Instead, the object will keep moving with the same uniform speed. There won't be any change. Right? So if we try to define, if we define balance forces, we can say when balance forces are acting on any object, then the object will either remain at rest if it is already at rest, or it will keep on moving with the uniform speed without any change in speed or its motion. Right? The speed will not increase or decrease. So a moving object may also be being acted by some balanced forces. Now, another important thing is here, if we want to find out net force. Now, what is this net force? Net force is nothing, it is the total force. Right? So here, if F1 is equal to F2 and the direction is opposite, then if I just use simple mathematics, and if I take 2 on this side, it becomes 0. Yes? So F1 and F2 are equal, but if I take it on this side, then the net force becomes 0 because they are equal. Right? Another thing, what if the forces are not equal that we were discussing before, then the object will, if it is at rest, it will start moving. If it is in motion, its speed might increase or decrease. In that case, net force will not be 0. In that case, there would be some value of net force. Right? See, if F1 is higher, then the net force will be F1 minus F2. If F2 is more, then net force will be F2 minus F1. But it won't be 0. It won't be equal to 0. It will be greater than that. Right? So, this is about a general explanation of balanced and unbalanced forces. You can take many examples. You can take the example of rope pulling. Right? You must have observed this game in which 2 teams are there and they pull the rope in either sides. Right? Now, if both the team apply equal force, then obviously the rope won't move any side. Right? Why? Because the force is equal but the direction is opposite. Net force 0. There won't be any movement. Right? But if one of the team is stronger, then what will happen? The rope will move towards the stronger team. Yes, why? Because the force applied by the stronger team would be more, and the force applied by the weaker team would be less, and the net force will be force applied by the stronger team minus force applied by the weaker team. Yes, and the rope will move. Yes, so that is unbalanced forces. Simple. Alright, so I'm sure it is clear to everyone what are balanced and unbalanced forces. Let us write this down properly. This is the proper language which you should write down and remember. See, there are a number of forces acting on an object. They might be either balanced or they might be unbalanced. Now, what are balanced forces? If you should carry a notebook and a pen with you whenever you attend the class, and please write down, make your notes. Okay? So what are balanced forces? You can always pause the video, write it properly, and then continue. If a number of force acting on an object does not produce any change in state of rest and motion, uniform motion, or direction, they are said to be balanced forces. Right? So if it is moving, it should keep moving with the same uniform speed, And if it is at rest, it should remain at rest. There should be no change in the state of rest or uniform motion or in the direction. Then those forces will be called balanced forces. Now you can take the example of balanced forces. A person holding a briefcase in his hand, a book which is resting on a table, squeezing a lemon, you're squeezing a lemon, then it is also a balanced force. Okay, now unbalanced forces. If the number of forces acting on an object produces a change in its state of rest or uniform motion or the direction, then they are termed as unbalanced forces. For example, a briefcase released from a hand of the person, then it will start moving. A stone dropped. There could be many examples. I took the example of the rope pulling game also. So by these live examples, you can always understand what is balanced forces and what are unbalanced forces. Balanced forces, value would be same, magnitude will be same, direction would be opposite, and net force will be zero. There won't be any change in the state of rest or uniform motion. In case of unbalanced forces, one of the forces acting would be having a higher value. The direction would be opposite, obviously. There would be some value for the net force, and there would be change in the state of rest or uniform motion or the direction. So this is how you can classify balanced and unbalanced forces. Right. So now, after this, let us understand various types of forces. So balanced forces and unbalanced forces was a classification 2, and this is the classification which is widely covered. It covers most of the forces. See, forces are classified into 2 types: contact forces and non-contact forces. Now, contact forces are further classified. You have muscular force, you have frictional force, and one more classification can also be added here. You have normal force. Right? So you can classify it into 3 types. One is muscular force, frictional force, and normal force. So these are contact forces. Now non-contact forces: gravitational force, electrostatic force, and magnetic force. Right? You might find the terms quite big and difficult, but they are not. We'll understand each and every force one by one. Let us start with contact forces. See, as the name suggests, the contact. What does this mean? It means these forces comes into action when 2 objects, they come in contact with each other. Means they're touching each other. Right? Like this pen I'm holding with my hand. So I'm getting my hand in the physical touch of it. Right? If I'm trying to push this, for pushing this, I will have to touch it. Right? So the forces in which 2 objects, they are in contact with each other, they're touching each other, those forces are called contact forces. See the definition: forces which acts on a body only when the body is in contact with another body. That is exerting force. The force is known as contact force. So, जैसे नाम बता रहा है, like contact forces are the forces which comes into action when 2 objects are in contact. The types, let's study the types of the contact forces. Normal force. Now understand what is normal force. See, let us take an example of a book which is resting on a table. Right? You have one force acting downwards. Obviously, that is the weight of the book. Right? Now, if there won't be any other force balancing this weight, this book might go in the direction of weight, that is towards the center of the earth. But it doesn't happen. Why? Because the table also applies, when table and book are in contact with each other, the table applies a force on the upward direction onto the book, right? Which is equal to the weight of the book, right? So, due to the balanced, we already studied balanced forces. Now these becomes balanced forces, and balanced forces, they do not let the book which was resting on the table move in either sides, right? So that is why the book is at rest. Why? Because of the balanced forces. We were talking about normal force. Normal force comes into action when two objects, like in this example, this table and the book are in physical contact, and the table applies an upward force, perpendicularly upward force, which is called normal force. See, if contact force between the bodies is perpendicular to the surface of contact, perpendicular means this is 90 degree. Yes? Perpendicular to the surface in contact, then the force is known as normal force. Similarly, if you can see this screen or this computer is placed on the table, then this table is applying a perpendicular force onto this screen, which is normal force, which is acting on this television or the screen, right? So I'm sure normal force is clear. Let us understand it in another way. Say, this is my hand and I've kept this duster over here. Now my hand is applying a force which is in the upward direction, right? Due to which this duster is not going down. If I remove my hand, this will fall. Yes? Why it is not falling? Because the weight of the object, the weight of the duster is being balanced by the normal force, which comes into action when this hand is here or some table is there. That particular table or the hand, when these two come in contact, then this hand is applying a normal force, which is why we call it normal, because it is perpendicular to the surface. Is it clear? All right, great. So let us move on to the second type of force, which is force of friction. Now see, force of friction is also a contact force, so it will come into action when two objects are in contact. But see, here it will not be just placed, we'll try to move it, right? So what we'll do, two bodies placed in contact can exert force parallel to the surface. Now normal force was perpendicular to the surface. Here the frictional force would be parallel to the surface in contact. Such a force is called force of friction, or simply friction. It always opposes the motion of the object. Means, you can see this, the green one is one object and the other color, the blue one, is being, this box which is blue is being pushed, right? Now, when we start pushing it to move, in order to move it in that particular direction, there is a force which comes into action, which is parallel to the surface in contact and which is opposing the direction of motion, right? This force which opposes the motion and comes into action when these two objects are in contact, and this is always parallel to the surface. This force is called force of friction. So what you need to remember in case of force of friction, Two bodies placed in contact also exerts force parallel to the surface in contact. Such force is called friction force, and it always opposes the motion. Is it clear? Very good. Let us move on to the third type, and the third type is muscular force. We all are aware about this muscular force, and muscular force is used many times every day, every work we do. If we push something, if we carry a bag, if we do cycling, if we carry some books to the staff room, whatever we do, in that the muscular force is required, right? So, but again, it is a kind of contact force because you cannot apply the force without coming into contact, right? Because you cannot do cycling without sitting on the cycle. You cannot lift the books without touching them. So again, muscular force is a kind of contact force. It is the third type of contact force. This is the force we can exert with our bodies by using muscles. Example, we can pull, we can push, we can kick someone. Such forces are mechanical forces, and these are also called muscular force. Right? So this is about the muscular force. Now the second part, which is non-contact forces, right? Now non-contact forces, as the word says, when in contact forces, two objects were in contact with each other. Obviously, in non-contact forces, the objects will be far away from each other. And in that case, also, the force would be acting. So, non-contact forces are forces which acts on the body when the bodies are not in contact with another body. The force is known as non-contact force, right? So now this time the objects will not be touching each other, they will not be in contact with each other. The example is gravitational force. Now in case of understanding gravitational force, the best example is of the Newton, the apple falling down. See, apple is never touching the earth. Still, earth attracts it toward it. Right? And everything, if I drop this pen right now, the earth will attract it without being in touch or without being in contact. So, the force which acts between two masses, any two objects which have some mass, they attract each other with a force. This is a natural force and it is called gravitational force. The force of attraction between any 2-point particles in the universe is called gravitational force, right? Example, you can see there are two masses here, m1 and m2, right? And m1 is attracting m2, means object 1 is attracting object 2, and object 2 is also attracting object 1. So again, there are two forces acting on them, F1 and F2, right? And these forces, this force is called gravitational force. The objects are not in contact, still they are attracting each other due to the masses. This is gravitational force. What is the value of the gravitational force? This is the formula for gravitational force, which says G, capital G, multiplied by m1, m2 upon d squared. D square is the square of the distance between them. Right? These two objects are d distance away, so square of the distance between them. Right? Although this formula is not required by you to study right now, this will be there in the chapter gravitation in your class 9th, but still you can just remember the formula. Here capital G is, it is called universal gravitational constant. This is a constant which is used. M1, M2 are the masses of the object. These are masses. And D is distance between the objects. All right, so this is all about gravitational force, which you have to understand, right? The next is electrostatic force. Now this is amazing. See, you must have tried this in the birthday parties or some any of the parties. What we do is, in order to stick the balloon onto the wall, you rub it on your head and just paste it on the wall. The balloon gets stuck to the wall. Why does it happen? Similarly, this game you must have tried. You can rub the comb, or you can rub a plastic scale on your head, and then you can try picking up the small pieces of paper, and you'll find them that scale starts attracting the small pieces of paper. Now this is happening because of the electrostatic force. Now sir, what is electrostatic? See, electrostatic is force applied by static charges. Static means stationary. Stationary means at rest. So whenever two objects are charged, in this, by rubbing, what we have done is we have charged the plastic comb or scale, and by tearing the small papers we have charged it also. So two charged objects, they either attract each other and they might also repel each other. In this case, one get positively charged, another get negatively charged, and they attract each other. So what is electrostatic force? The force existed by charged bodies on another charged body or uncharged body is called electrostatic force. Right? So those charged objects, when they attract each other, two charged bodies or two charged objects, when they attract each other or repel each other, or one charged object attracts an uncharged or repels an uncharged object, then what happens? The force which is acting between them, it is electrostatic force, and here again the objects are not in contact. Right? Is it clear to everyone? All right. So let's move to the another part, which is magnetic force. Magnets, you all have seen. Magnets, a magnet, you keep a magnet and you place some pieces of iron near to it, it will attract it. Again, the iron pieces and the magnet, they are not in physical contact, but still they attract, right? Another example, you can take two magnets, and if you keep their opposite poles together, then they will attract, and if you place the same poles nearby each other, then they will repel, right? So this is the force which is applied due to the magnetic field, or you can say magnets. They are called magnetic forces. See the definition. A magnet attracts iron filings, nails, and other objects made of iron, steel, nickel, or cobalt. Magnet exerts a force of attraction or repulsion onto the magnets also, the second part which I explained. The important feature of magnetic force is that it can act from a distance, and it is therefore called a non-contact force, and it is a type of non-contact force because it acts from away. Two objects are not in physical or touching each other, right? So this was about magnetic forces. So for today, this is enough. I hope you would have understood balanced forces, unbalanced forces, and types of forces. Now the next topic we'll be studying in the lecture 3, and we'll finish up this chapter, but we'll also solve some numerical problems, and I'll tell you, like the previous lecture, I'll tell you how to solve the numericals. Don't be afraid of numericals. They're very simple. I'll tell you the method, and you will be damn surely you will be solving them correctly. Do not worry. All right, so that's it for today. Thank you so much. Have a nice day. Bye-bye.